Hello everyone. In this video, we are going to discuss about resistors connected in series and parallel. Okay, let us start with resistors connected in series. Here we can see two or more resistors when connected in series, the current flowing through them remains the same. The same current will be flowing throughout the circuit when connected in series. Here we can consider three resistors R1, R2 and R3 connected in series, and the current flowing in this circuit or the resistors, let it be the current I. Now applying KVL, Kirchhoff's voltage law. To know about the Kirchhoff's voltage law, click on the link. Now applying KVL, around this loop where the current flowing is I. Now this I will be equal to Kirchhoff's voltage law, or we can say the voltage V. Sorry, it's not I. Voltage loop V will be equal to the voltage drop. Here it is I into R1, and here it is I into R2, and here it is I into R3. Now the total voltage rise will be equal to the voltage drops in the loop. Now V is equal to, if we take the current common, I will be left with R1 plus R2 plus R3. Now V is equal to I into R equivalent, where R equivalent is taken from R1 plus R2 plus R3. From this we can say the resistors connected in series, the equivalent resistance will be the sum of resistors connected in series R1 plus R2 plus R3, and the equivalent resistance will be greater than the maximum resistance value connected over the circuit. Okay, now moving on to the resistors connected in parallel. Let us consider resistors connected in parallel with a circuit as shown here. We have taken an example where the current I is divided into I1, I2 and I3 across the resistors R1, R2 and R3 connected in parallel. Here also two or more resistors will be connected in parallel, so that, remember, one point is very much important here: the source voltage is applied across the resistors remains same in all the three cases, R1, R2 and R3. In this case only we can say the resistors are connected in parallel with the same voltage applied across the resistors. Now for this circuit, if we apply KCL, to know about KVL and KCL, click on the link above here. Applying the KCL current loop, I is equal to I1 plus I2 plus I3. The current I will be divided into I1 plus I2 plus I3 at this junction, at junction J1 or any node here. Now for this, I is equal to, now what is I1? I1 is the voltage applied across R1 is V, therefore V divided by R1 plus the value of I2 is V by R2 plus I3 is V by R3. As we already mentioned, when two or more resistors are connected in parallel and the same source voltage is applied across all the resistors, same source voltage is applied across R1, R2 and R3. From that we have taken V by R1, V by R2 and V by R3. Therefore I is equal to, if we take V common, we will be left with 1 by R1 plus 1 by R2 plus 1 by R3. Therefore, I is equal to V into 1 divided by R equivalent. Where from this we can say R equivalent, or we can also mention it as 1 divided by R equivalent is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. From this equation, we can say that the value of equivalent resistance is always less than the lowest resistance connected in the parallel circuit. Okay, this is the equation for equivalent resistance for parallel connected circuits, and this is for R equivalent for series connected circuits. Hope you people understood. If you have any doubts, please do comment below. Thank you.